I'm assuming you all remember the import random that we taught you a while ago. Remember the import math as well that we taught you? The import random is going to be a very useful tool. I'm going to use that now. And then if I say print random, you know what that does? Execute this. It shows me a random number between 0 and 1, as you can see in the terminal. Right? So what I will now do is, instead of printing a random number, I'll delete this. I'll initiate a list L and I'll append a random number. Alright? And then now if I print L, what will it do? It will create a list and it appends a random number between 0 and 1. And then, assuming I keep doing this, and then again print L, it will keep it displays L with one number included, and then with the same L I append another random number, and here's another random number, and that again gets displayed here. So spend a minute, pause the video and try to see what am I typing here and what is the output here. Alright, so what I'll now do is, I will not type this twice, I'll type this maybe 10 times. So how do I do that? For I in range 10, yes, perfect. I say L append random and then print L. This will give me okay, you see what's happening. I'm printing the list every time, so it is displaying every time a random number gets appended. So if I remove the tab, it means this comes outside the for loop, and as you would expect, what should be the output here? Let's execute it. It will show the list only once because you are displaying it only once. You have removed that from the for loop. Alright, to avoid confusion, maybe it will also help if I put another enter here, empty line here. Alright, so I do have these 10 random numbers here. As you know, we also have what is called the rand int, and I can say 1, 10. Let's see what this does. It simply appends a random number between 1 to 10 here into this list. So the fun part about computers is that you can simply increase these numbers and boom, it becomes 10, became 100. Right? I'm appending 100 numbers here. So please note, it started off with 1, but it starts with 9 here. That's because it's a random number that you are appending, and you're executing the program afresh. That's why it doesn't append to this list but starts a new list every time we execute this program. So what I'll do is I'll keep this in the middle of the screen so that you can see it. Better even clear the screen. Okay, as you can see now, instead of 100, if I do, let's say 10,000, it will indeed show 10,000 entries. Boom, look at that. It was really fast. You can add many numbers and you can observe that it's a lot faster than what you would expect it to be. So I'm now appending 1 million numbers. Man, it takes time, but it does get back, as you can see. So many numbers, and you can let's say, let me just reduce this by I'll keep it 100,000, and then which is like 1 lakh, and then include random numbers from 1 to 100. Or maybe 1 to 1000. I'm executing. You see, you see numbers from 1 to 1000 randomly put here. Why would I do something like this? Okay, so we are heading towards a topic that you studied in computational thinking, the birthday paradox. Okay, before that, we would like to see how we can model it using Python. So what exactly happened in birthday paradox? Let me try changing these values, and you will probably quickly say, Eureka! You found that out, in the sense that you understand what I'm trying to say. What is this? Let me clear the screen this side. Okay, what is this? I'm saying create a list L. So as I've been telling, it's important to type comments. create an empty list, or rather initialize an empty list. Okay. What I do is append random numbers between 1 to 365. How many should you append? Append 30 of them. Right? Let's see if this is what is happening. I executed, and you see this is precisely what's happening. You have 30 random numbers between 1 to 365. As you would have guessed, 1 to 365 stands for day in a particular year. So if I am born on January 1st, the number is 1. If I am born on December 31st, the number is 365. Alright? So when you pick 30 people and ask them for their birthday, their DDMM, day and month, not the YY, if you remember. You don't look at the year of birth in the birthday paradox. If you're wondering what we're talking, you may have to revise your computational thinking course, this part where the instructor discusses the birthday paradox. In fact, it's a very interesting discussion as I have watched, and there's a surprise factor there that even if you take a very few number of people, you will get 2 people with the same birthday. Right? So I have taken 30 people here and I'm going to execute it. I've got these numbers. So you got to tell me if there's any repetition here. Right? So I do not see a repetition, or maybe I'm bad at seeing if there's a repetition or not. There's a nice way to do this. This was your L, right? Yeah, so if you're wondering what I'm doing, whatever you have written here, those variables can be called here too. L had these numbers, I've included L. There is something called sort function built within the list. So when you say L.sort, it simply sorts it. Okay, again print L. Now it's easy to see if there is repetition or not. Let me check. 154, 167, there's a repetition. And what does it say? It gives a proof that birthday paradox indeed seems to be true. Why? As you can see, when you pick 30 random numbers from 1 to 365, this tantamounts to, this translates to you going on the road and stopping some 30 people and asking them for their birthday. Of course, you shouldn't do that. Nobody will tell you their birthday, especially on the road. But if you randomly pick some 30 people, let's say from your friends or in a classroom, and ask them for their birthday, you will observe that 2 people will have the same birthday. Right? So you must be wondering, is this always true? Not really. This may not really be true. I'll show you an example. Just a minute. So let me put SL sort here itself so that it displays now a fresh bunch of 30 people. I see, is there a repetition? 86, 87, 91, 119, 143. There is no repetition here. Surprisingly, there is no repetition here, which means this is not always true. If you take 30 people, here and there it may fail. I'm repeating it once again. 32, 32, bingo, there's a repetition here. I'll repeat once again, and let's see, there is no repetition. 129, 129 is a repetition here. Okay, only here there was no repetition, right? So, or did I skip seeing that? It's very difficult, right? So 143, etc., there are no repetitions here. Okay, so why should we do this manually? Why can't we write a piece of code that checks if there's a repetition or not? How do I go about it? So it's pretty simple. What I'll do is I'll say while I is less than or equal to length of L minus 1. What does this stand for? Always length of L will tell you the length. Okay, so how many entries are there in L? I should take minus 1 because I need to go up to the 29th element. You see, length of L minus 1 will be 29. Please observe carefully. When I say L of 0, it gives me the first element of L, 36. Right? When I say L of 1, it gives me 66. L of 2 will give me 85, and so on. What is L of 28? Can you guess? L of 28 is what? 313 or 320? Think about it. It is 320. Alright, so what is L of 29? The last number 341. If this one is 0th element, this should be 29th element because the sums are, it totals up to 30. Okay, so what is L of 30? Boom, it'll punch on your face saying there's an error, right? So I will go up to len of L minus 1. Okay, so what's the syntax? I say colon here and then go here. I don't like this error messages, so I'll scroll up a little. Right? Okay. So so I say while I is less than or equal to len of L minus 1, what you do is, just in case, if L of I is equal to L of I plus 1, then I say print there is a repetition, repeats. Okay, else does it repeat? Okay, it matters for me to make some errors in my code, then you will realize what goes wrong here. So I should be doing this. You see what will happen if this happens. If L of it starts with 0, basically I should be equal to 0. I is 0. 0 is less than or equal to len of L minus 1, which is true. It comes inside. Is L of 0 is the same as L of 1? So let me go ahead and then see that array here. So it will just let's use this as the array. L is this here. Okay, so let me print L so that it's clear to you people. So L of 0 is 36. Is 36 equal to 66? No, it is not equal. So it doesn't get repeated. And it says doesn't repeat. No, that is not true. I want to go until the end and then say doesn't repeat. Okay, so I'll do a small trick. It may take some time for you to understand what this trick is. The trick is, I'll say flag equals 0. Okay, which means denotes that there is no repetition. If flag equals 1, it means there is repetition. What does it mean? It will be clear in just a minute. So whenever there's a repetition, I say flag equals 1. And then once you see the repetition, you may want to come out of the while loop. Why should you stay there? Correct? Okay, perfect. And this is not required. Why? Why? Because translating this to simple English, at the end, in case you never enter the if loop, it means you have not seen two elements which are equal, two consecutive elements that are equal, which means flag never becomes 1, which means your flag is 0. Then I say if flag is equal to 0, then I print doesn't repeat. There is no repetition. Okay, there is no repetition. Now, there is a small problem here. I goes up to len of L minus 1, right? Your I should basically be incremented every time. I equals I plus 1. Why is that? It's because the while loop ensures that I is less than or equal to len of L minus 1, and you should keep going to the next I equals 0, I equals 1, I equals 2. That happens when I equals I plus 1 is stated here. Alright, stare at the code. Pause for a minute and stare at the code. Alright, keeps incrementing, and the last time the moment I becomes equal to len of L of minus 1, which is in this case, as you can see, len of L is 30, len of L minus 1 is 29, and L of len of, let me call this I equals len of L minus 1. Okay, and then I say what is L of I? L of I is 341 in the last step. Okay, and then when I say L of I plus 1, it throws an error. Alright, because L of I plus 1 becomes L of 30. L of 30 is not here at all. So you should not be comparing L of 29 with L of 30, which means you should not go till the last step. You must go to the second last step. So you should stop when I equals 28, which means you should not go up to the length. You should go up to the length of L minus 2. This is getting complicated, and I'm sure you're confused, and that is what you mean by programming complexity, right? When you're thinking, I'm thinking aloud and I'm coding. I have not typed this code before. I'm going very slowly, just trying to understand what is what, translating my common sense to English and that English to a program, right? So now here is my code. I have a feeling this is perfectly written. This should get executed. Let me see what goes wrong or if it goes right. Okay, so I'll execute this. It says there is no repetition. I hope there is no repetition. Let's check. I think there is no repetition. Good. 186, 197, 213, 231, 232, 237, 243, 257, 270. Boom. There is no repetition. All right. But if I execute the same thing again, it says repeats. Where does it repeat? It repeats somewhere here. Let's see, where is it? 55, 58, there's a repetition. Right? So it says repeats. So I can trust my code now. Why should I go and see where it repeats? Why can't I display where it repeats? When I say print, it repeats. I can also say it repeats in the particular place. Let me just write it next to repeats. Repeats L of I and L of I plus 1. Basically, they both are the same. It should display the numbers twice. Repeat 77, 77. Ooh, that's awesome. But then you see 99 and 99 is also repeating. It's not showing that. That's because I keep saying your computer is dumb. It only does what you specify, what you ask it to do. The moment it repeats, you're coming out. You're saying break, stop. I have seen a repetition, right? When you're checking for 30 people, the moment you see 2 people with the same birthday somewhere, you stop. Alright, by the way, they don't come in this ascending order. We are sorting the list. That is why it is being displayed in ascending order. You see? Alright, so the moment you see the repetition, you stop. You may not want to do that. Maybe you can modify this code a little. I'll leave that as a homework. It is pretty straightforward. We'll take another 20 minutes of our time. I'm not ready to spend that right now, but I want this as an exercise that you can take home and then try to figure out how to do it. So what you should do is you should show the repetition and you should also show all the repetitions. Okay, which means once it repeats, you should not break. You should come once again and then check whether it repeats or not. Alright, sometimes it may repeat thrice or 4 times, 5 times. Okay, you should be able to see that. Alright, there is no repetition. Repeats. Looks like every now and then it doesn't repeat. There is no repetition once again. Let's try executing this again and again. No repetition once again. Repeats 2 to 5, 2 to 5, as you can see. Okay, so let me clear the screen so that it's easier on your eyes. There is no repetition. Once more, no repetition. Repeats 220, 220. Repeats 64, 64. 222, 222. There is no repetition. So what do we do here? Why is there no repetition occasionally? Not occasionally, almost 1 in 2 times when you run this experiment. How many times have we run here on this page? No repetition, no repetition. Repeats, no repetition. 1, 2, 3 times no repetition. 1, 2, 3 times there is repetition. It means repetition happens only half the times. So shall we go to our computational thinking professors and tell them this repetition is not happening. But you taught us that repetition is very probable. I mean, with a high probability it happens. But it's not happening here. It's not happening with a very high probability. It's happening with, let's say, probability half. Half the times there is repetition. And your computational thinking professor will say, that is expected. Why is it expected? That's expected because you're taking only 30 people. Try taking 50 people and you will see the magic. I have taken just 50 people. This entire program, I just go and simply make this 30, 50. That's all. And I run the experiment. I repeat, note the phrase, I run the experiment. I repeat, I run the experiment. You probably are thinking I'm mad. I'm repeating the same phrase again and again. There's a reason for it. I run the experiment. I'll tell you in a while why I'm saying it again and again. I run it once again. There's a repetition. Run it once again. There's a repetition. Run it once again. There's a repetition. Let me clear the screen. Not here. One moment. Clear the screen and then repeat the experiment. Repeat the experiment. Twice, thrice, 4 times, 5 times, 6 times. Wonderful. I repeated it 6 times, and at all times it says repeats, 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 and repeats. We did not encounter a situation where it doesn't repeat. Okay, there's no repetition. 7th one, it says no repetition. Okay, but then again repeats, 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 repeats. Repeats, 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 repeats. You see, once in a while it says no repetition. Okay, I'm yet to encounter no repetition right now. Let me keep going. I have all day. Repeats, 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 repeats. I'm getting slightly tired now. Repeats, 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 repeats. Okay, come on, please show us one no repetition so that I can tell them that it is not always green, it can be red too. We indeed saw once, but yeah, looks like this will go on and on. Alright, in fact, you can put in a loop here and then try to figure out how often does it repeat and how often it doesn't. Okay, so we had 30 here, we made it 50, now I'll make it 20. You will see many a times that it will not repeat. You see, repeats, no repetition. Clear the screen. Okay, no repetition, no repetition, no repetition, no repeats, 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 repeats. Oh God, what's happening? Repeats, there's no repetition, repeats, there's no repetition, repeats, there's no repetition, right? So it happens more frequently than for 30. But for 40, 50, it never repeated. Okay, but if you put some 75 or something, you may have to wait for a long time before you see a no repetition. Definitely there will be repetition. In fact, there will be many such pairs. You will observe that there will be many such pairs. As you can see, I'm just quickly seeing there is a 364, 364 here. The repetition 105, 105, though, hey, it says 105, 105. There's also 299, 299. I see 231, 231, 231. Oh, there's a triplet here, not just a twin. You see, repetitions, not just 2, but 3, 4 starts off as you increase the number. Let us run the experiment, I said. The word experiment. What did I mean by that? You need not go to the roads or go to a classroom and then run this experiment. Okay, you see, you noted that in the computational thinking course, the professors were using the cards to show you that the repetition happens. Is that really true? You can come here and run an experiment on your computer, repeat the experiment many times, and then say that this is indeed true. When you repeat the experiment, this paradox called the birthday paradox is something that is tough to believe but is true, indeed is visible here in this experiment, where you pick numbers from 1 to 365 uniformly at random a few times, put them into an array, sort it so that it's easy for you to see repetition. You will see that there are repetitions. Right? I hope you enjoyed the piece of code here. What we did just now is called simulation in the language of science. It's called the scientific simulation. Many researchers do this and they write research papers based on this. You can in fact simulate how COVID disease spreads just on your Python compiler. You can simulate how the stock market works just on your Python editor. right? So this was a good introduction to what you mean by a simulator, but then what interests us the most right now is confidence to write a piece of code. We just now wrote a nice piece of code which told us indeed birthday paradox is true. So from now onwards, whenever someone says something, if you think that's numerically possible to simulate, you should quickly switch on your computer, write a piece of code, and then analyze the output of the code.